Is that everybody there? Apparently, yes. First, let me see. Yeah, everybody is there. Okay. Lamai, I hope everybody is there. So let me know. I know that two of you are there because you just joined now. Others, just drop me one or two messages whether you are available now. Okay, enough. Now write this in a new line as an example. Write a car of mass 1000 kilogram, car of mass 1000 kilogram, which is moving under velocity of 10 ms minus 1 collide against another mass of 1000 kg. Cow 1000 kg, another cow, mass of 1000 kg, which stay at rest. Which stay at rest. And due to the collision, both both the cars stick together and move forward in the original direction of the first car. Stick together and move forward in the original direction of the first car. Let's write this in a new line. Question: find out the velocity of the combine. Find out the velocity of the combine. Try to find out velocity of the combine. Okay. Time හැමතිස්සෙම අදින්න ඕනේ. විනාඩියක් ඉතින්ම වාගෙන ගන්න. Only 1 minute even for you. So 2 minutes දෙන්නම්කෝ. විනාඩි දෙක හිතින්ම වාගෙන කරන්න. Both the answers are correct. Others? Anit lamai? No, your answer is wrong. It's not. Okay. Now I am going to solve it. It is like I consider the first one as M1 and mark this one as V1. And here, before collision, this one is M2 and V equals to 0. This is what? Before. Let me show you what happens after. M1 and M2 together with the velocity of V. Let me write it like M1 V1 plus M2 times 0 equals to, what about the final one? These two join together, M1 plus M2 times the common velocity of V. Common velocity of V. So this one cancel off. M1 V1 equals M1 plus M2 times V. So what is my velocity is going to be? V equals M1 V1 over M1 plus M2. So what is it? It is 1000 over 1000 plus this one is also 1000 times V is what? 10. 1000, 1000 cancel off. So it is like 10 over 2. It is 5 ms minus 1. Am I clear? Am I understood? Guys, let me know. Am I understood? මම කිව්ව දේ තේරුණාද? Good, 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 good. You want to eat? Copy this. Okay, guys. I think I gave you enough time to process this. So after this, let's straight away go to real calculation in a question paper. So as I told you, I leave the space for the previous one. Here I left this space, I didn't do anything. Now let's try for everybody who has done this and hasn't done this. Regardless of this, let's try this entire thing. Now I'll give you 6 minutes because giving more time is good for those. Giving more time is horrendous for those who can't do it. So thinking of everybody, I will give you the maximum time of 6. Let's start. By the way, this is in the tute, previous week tute, the term test paper questions thing. If you don't have the tute, so look at this one. So I'll minimize the size so you see this. If you don't have the tute, look at the screen and do. Somehow try this. Okay, recording its progress like a frog. Have a look at. A ball of mass 0.1 kilogram is sliding with 1.4 ms minus 1 horizontal top and negligible friction as shown in the above. It makes collision with ball B 0.5 and at rest and edge, and as a result of the collision, the ball A rebound. This one rebound back with what? 0.7. Immediately after the collision, calculate the speed of the ball V after the collision. Okay, let's see how. We should know that before should be equals to after. What is before? MA V1 plus MB times 0. What is after? MA times 0.7, but that is in negative direction, plus MB times V, I don't know. So what should I do now? I have to write like 0. Sorry, wait, let me write MA V1 plus this one is going to cancel. So minus MA times V2 plus M3 MV times unknown velocity of V. What is it going to be? M1 V1 plus, sorry, MA V1 plus MA V2 equals to MB V. What is V? MA is equals to what? MA equals to 0.1 times 1.4 plus 0.7. That's equals to what? MB is 0.5. Is that 0.5? Yes, that's 0.5. What is my top answer? It's going to be 0.1 times 2.1 over 0.5. So what is it going to be? 2.5 over 1 over 5, that's going to be like what? 0.42 ms minus 1. Did you get this answer? Did you get this answer? Yeah, very good. Very good. Now it asks you what? Find the energy of the system before collision and after collision. So this part I will leave, and this part I will leave. But I will do, but I don't expect you to do. System before. Before what? Only A was what having EK initial what? Half 0.1, and what is the speed? 1.4 square. After what? EK after what is it? Half 0.1 times 0.7 square plus what? Half 0.5 times 0.42 square. මේ කතන්දරේදී ඔයාලට දැම්මම වැදගත් නෑ. අනිත් එක මේ ගණන් හදන්නත් එපා වෙනවා. වැඩි ගන්න එපා. So මේකයි සමානයි නම් perfectly elastic, නැත්නම් perfectly elastic නෑ. Right? Considering the motion of the ball B after the collision as a projectile motion. මම මෙතන ඉඳන් right බලන්න ගන්නවා. Find the total flight of the ball B. Time of the flight is only determined by the height. This one. No. No. You don't want to. Because at the moment, during collision, you don't want to worry about the potential in it. Now the collision, the projectile is something like this. This is 1.2 meter. So vertical stuff is the one which determines the time taken, because these two times is the same. So according to condition, u equals 0 and v equals something I don't know, but h is 1.2 and the acceleration is gravity. So you can write what? S equals to half gt square. 1.2 equals to half times 10 times t square. So what is my answer is going to be? 2.4 over 10 equals to t square. T equals 0.24 and root of it. So this is how you find time. When you find the time, you can find the horizontal range. How? Horizontal range is the one determined by velocity of fuel, horizontal, and the time of t. Here, what is my time? Velocity. I just found 0.42 times root 0.24. Using that one, you can find out the horizontal range. The ball is replaced by a ball C of mass 0.1. Consider the collision A and C perfectly elastic. Now find the new speed of ball. Obtain the same horizontal range in the calculated the part A. Now we have to use for kinetic energy. We are not ready for that, because why? Kinetic energy I didn't teach you so far. All level is not enough. So let's do it another week. Now these type of applications are the ones you will find in the momentum theory. Right. So we haven't done with the A-level type of things so far. Now we have to go for another new theory. Write this task. elastic and inelastic collisions. Topic is elastic and inelastic collision. Inelastic collisions. Write it. Elastic and inelastic collisions. What is the meaning of inelastic? What is the meaning of elastic? Correct? Now write this in a new line. Subtopic elastic collisions. යා මෙතන මම ඉන්දියාපුර ලියලා නැහැ. මම මෙතන ලියලා inelastic මෙතන අයියාපුර ලියලා ඉක්වාට. හරි. හරි. Elastic and inelastic collisions. යන්න elastic collisions කියලා අලුතෙන් දාගන්න. subtopic එක. යන්න collisions with initial and sorry so collisions with initial and final kinetic energy equal kinetic energy equal kinetic energy equal kinetic energy equal are known as perfectly elastic collisions. That means if it had the kinetic energy of K1 before collision and after collision it's K2, remember that total kinetic energy should be before and after should be equal. If the before thing is like 10 joule, after thing it should also be 10 joule. Write this in a new line. In nature, real elastic collisions are unavailable. In nature, real elastic collisions are unavailable. Write this in another new line. Write this. But collision among air molecules and collision among billiard boards on a billiard table, are considered to be nearly elastic. It's not absolutely elastic, nearly elastic. Okay. Now write this in a new line. Nearly elastic. A new topic. Inelastic collisions. Inelastic collisions. Inelastic collisions. What is inelastic? All right. Collisions with energy lost is known as what? Known as inelastic collisions. Write this in a new line. All the real collisions are inelastic. All the real collisions are inelastic because it converts energy into some other forms and not remaining as the kinetic energy. So it is inelastic naturally. Now write this in a new line with a double star point. Whether the collision is elastic or inelastic. Write this in a new line. Whether the collision is elastic or inelastic. Collision is elastic or inelastic. It is considered to be momentum is always conserved. Momentum is always conserved. Right? Energy might not be conserved, but momentum is always conserved. Right? හරි. මම මේක මොලිකියුල් වයිස් කියලා දෙන්නම් next week එකේ. ඇයි එන sorry. මම මේක කියලා දෙන්නම් kinetic energy කතන්දරේ කරලා ඉවර. මොලිකියුල් වයිස්ම කියලා දෙන්න. දැන් මේක කිව්වට තේරෙන්නේ නැහැ kinetic energy ඉවර වුණා. Right? Write this in a new line. This lesson is thoroughly revised in energy lesson. Yes. Now we can't do much on this. Okay. I think you basically understood the very basic things that you need to know. Right. Shall we go into the tutor again? Shall we try this question? But this third one, there is a mismatch because it's a 1993 paper. All the paper books, it supposed to be like this. So it's very old papers. So can't find these. So it was really hard to find. How can I find? These papers are even for me to burn. But these ones, we can exam level. And question number 6. Let's discuss each of these quickly. You might have tried this. I don't know whether you tried or not. So there are like 5 questions to be discussed. The standard time allocation for this one is like 10 minutes. But you had the chance to do this in home even. If you didn't do it, your fault. So I'll give maximum of 5 minutes and try quickly. So I will teach you how to do this one. Because you had enough time to try this at home. Okay, a rail car of mass 5 m rests on a smooth horizontal track and engine has a mass of 3 m and rail car of mass 5 m rests on a smooth. Moving at 8 m is minus 1, collide and couple with the rail car and the speed of the engine after the impact is. Right, let me scale. This is the engine with a 3 m. Wait, wait. Engine. 3 m and 5 m and both collide together and merge and move. That means it's 8 m. You should have this sense. Like am is minus 1 and this is what we. So even I don't really want to do it. Because why? A rail car mass of rests on a smooth horizontal track and engine of 3 m at 8. So what is it? 3 times 8 plus 5 times 0 equals to 8 times b. හරියට බැලුවොත් හදන්න ඕනේ මේ මොකද 24 equals to 8 times b. B equals 24 over 8. That is 3. So if I were the one, I would just have a good look at this one is not moving. I know that 3 times 8 is the initial momentum. That is 24. I know the final mass is 8 together. And I have divided the total momentum by 8. It is to 3. So it won't need, you don't need to spend more than 20 seconds on it. තප්පර 20ක්වත් යන්නේ නැහැ. මම මේ දේවල් පේපර් ක්ලාස් එක පටන් ගත්තාම කියලා දෙන්නම්. මනින්ම පේපර් ක්ලාස් එක පටන් ගන්නවා. හරි? Soon. I will start a paper class really soon. So most probably around late May, right? Or early June. For my students, I normally going to charge like somewhere like 500 to 800. එච්චරවත් ඕනේ නැහැ. Free කරොත් මිනිස්සුන්ට කිසි වටිනාකමක් නැහැ. That's what. But for the others, I will charge somewhere like 2,500 to 3,000. So for you guys, I maximally charge like 750 or something. I can give it free, but it's not going to be useful. Right? How will I you? An astronaut of mass එතනදී මම මෙන්න මේ ටෙක්නික් කියලා දෙන්නම් මේ වගේ සනික ගන්න ක්‍රම. An astronaut of mass m is launched from surface of the moon in a spacecraft having an initial vertical acceleration of 5g, where g is the acceleration of 3-fold of the moon. The vertical reaction force of the spacecraft on the astronaut is. Okay, let's see. Right. Astronaut is sitting on here. He has his weight of g dash and he's getting accelerated and then 5g dash So what is the reaction? Because his mass is m. So downward force is mg. So the acceleration thing is mg dash. R plus what? R, sorry. The reaction equals to what? mg plus what? ma, that is again g dash. So what is it? 6 mg dash. Answer is this one. Now here, this is really important to know. An object, this is extremely important to know, but an object of mass 5 kg is subject to resultant force of F, which varies with time as shown in the graph. Momentum gained at the object is 10 seconds. So you know, as I told you, impulse is equals to force multiplied by time. So what is the area under the graph? Area is given by what? Force multiplied by time. I show you that in the last minute of the last class. Even today, I didn't have the time to explain you this one properly. So time has flown. Let me get the area. Area is what? A trapezium, as well as this part is a trapezium. This part is what? Yeah. The whole, it's a trapezium, the whole thing. How to get it? Area equals to what? 8 minus 2 is 6 plus 10 over 2 times the vertical height of is more like 5, 5, like 16 over 8 times 5 equals to the change of momentum. What is the mass here? It's 5. 5 times velocity, change of momentum. 5 equals to, no, they don't ask the velocity, only the momentum gain. Only the momentum. So 8 times 5 is what? 40 Newton second. A mass of 0.4 kilogram is suspended from a light spring as shown. A second mass of 0.2 is suspended from the first by thread. Okay. Okay. Now what do I need to do is like suspend from thread. When the system is equilibrium, that is burn. Now the thread is going to burn, right? When making for the initial acceleration of okay. So this is in equilibrium all because of what? This one and this one together. Now this one is going to miss. What is the additional thing caused by this one? Right? Okay. What is the additional thing? So it will store restoring force of what? Minus kx. But that minus kx was given by what? Weight equals to minus kx. You don't want to know, but you know the extra force that stored there was what? You don't know the spring constant even. What is the extra force? Extra force is the weight is extra force. The extra force is what? Weight. Okay. So how it is going to be? Mg equals to, now this extra force is stored in the spring. Remember that this was the extra force provided. Once it releases, it will act as if a force in the spring. මම සිංහලෙන් කියන්නම්කෝ. මේක ඇදගෙන ඉන්නේ කවුද? weight එකකින්නේ. weight එක release කරපු ගමන් spring එකේ තියෙන extra force එකකින් යනවා. ඒ දෙන්න equal. එයා සමාන වෙන්නේ මෙයාගේ මේ weight එක. So mg equals to capital M for the bigger one. So what is acceleration? mg over capital M. What is the mg? 0.2 times 10 divided by 0.4 is the big mass. So it is 5 ms minus 2. Answer is this one. You have to think a lot in that. And the last one, the ball of mass 0.5 kilogram, which is initially at rest, is stuck by a bat. The variation of force on the bat is time and the speed of the ball when leave the bat. You know the area under this one is the change of momentum inertia, that means change of momentum. So let's find it out. Area equals to this. So area is what? Half m, sorry, a into height. What is it? Half times 2 times 2 equals to what is 0.5 times that velocity. I don't know. 2 and 2 cancel off. V equals 2 divided by 0.5. That means 4 ms minus 1. Answer is this one. मैं MCQ पहा है කියලා මම තේරුම් නැති මොන හරි තියෙනවද? Is there anything that you can't understand here? Huh? Is there anything that you can't understand? තමයි මම දැන් මේ CQ පහේ කියලා දෙන මොනවා හරි තේරෙන්නේ නැති තියෙනවා නම් දැම්ම අහගන්න. නැත්තම් ඔහම මෙයා ඔයාලා ඔක්කොම නිදා ගන්න ඕනේ නැතිනේ ස්කූල් එකේමත් යන්න. කියන්න අදාලා එන්න පුළුවන්. ඉවරක් කරලා යන්න. Let me know. ළමයි චූටි දවවක් කරන්න. චූටි දවවක්. ඔයාලගේ තියෙනවා introvert nature එක පොඩ්ඩක් අඩු කරන්න. introvert උනාට කමන්නේ මම කියන්නේ මමත් පොඩ්ඩක් විතර introvert තමයි. බලහරි කැමති තනියෙන් શબ્ද නැතුව ඉන්න. ඉතින් මගේ ඩියුටිත් එක්ක මට හිත කරන්න බෑනේ. ඔයාලගේ තියෙන ප්‍රධාන ඩියුටි එක ස්ටඩි කරන එක. එතකොට ස්ටඩි කරනකොට සර්ස්ලා ටීචර්ලා එක්ක හොඳට කමියුනිකේට් කරන්න. ඒක අවොයිඩ් කරන්න බෑ. පොඩ්ඩක් ඉන්ට්‍රෝවර්ට් ගතිය පොඩ්ඩක් අඩු කරගෙන මැසේජ් එකක් ටයිප් කරලා එවන එකේ හාම් එකක් නෑ. හරි. ඒක කරගෙන next week එකේ අපි ප්‍රශ්න ටිකක් කරමු නේද? ඒකටත් උත්තර දෙන්න. ඕන්නම් එනර්ජි වලට යන්න පුළුවන්. law of energy කියන lesson එක. work, energy and power. Big lesson. But I recommend we have to do more questions. Firstly, I send you very sophisticated big worksheet. And in the next week, I also provide question paper for the session as well. Right? ඉතින් ඒ ඔක්කොම තියාගන්න මොකද මේකේ තියෙනවා හොඳ ප්‍රශ්න සෙට් එකක්. mid week එකනේ. mid week විතරක් නෙමෙයි ළමයි. theory එක කොහොමද දුන්නනේ? Can you remember? අද ඔක්කොම කරන්න අපිට වෙලාව නැහැ. මේවා ඔක්කොම කරන්න පුළුවන් නම් මම මිනිස්සෙක් නෙමෙයි ඔයාලත් මිනිස්සුයෝ නෙමෙයි. Right? None of us are going to be human. See, there are some understanding questions. Evaluate yourself. වාම ප්‍රශ්න ටික try කරලා බලන්න කොච්චර දුරට වань තේරෙනවද කියලා. මේ MCQs ටික හරි වටිනවා. Simple calculations are there and like this strategy. මේවා ටිකත් මම කතා කරනවා. නැතුව නෙමෙයි. ඊළඟට තව ප්‍රශ්න ටිකක් තියෙනවා. මේ සෙට් එක දැන් කරන්න බැරි කමක් නැහැ. මේ බුලට් වලින් ඒවා අරවා මේවා. මම මේවා කොහොම next week එකේ discuss කරනවා. තව extra ප්‍රශ්න ටිකකුත් එක්ක. එහෙම හොඳයි නේද? මම කියේ මෙන්න මේ exam level එකේ තියෙන සුපිරි එකක් කියලා මේ මෙන්න මේ දේවල් සේරම මම ඩිස්කස් කරනවා. එහෙම හොඳයි නේද? අලුත් ලෙසන් එකට යන්න කලින් මේක ටිකක් හොඳට ඉටිග්‍රීස් වෙන්න හදාගෙන යන්නේ. මට කියලා යන්න. ඔව්ද නැද්ද කියන්නේ? තමයි. ඔව්ද මම? එහෙම හොඳයිනේ. හරි. කලම මේ කියනවා හොඳයිලු. අනිත් අය කියන්නේ ඉතින් හොඳයිද නැහැ. මම ලබන සතිය කරන්නේ ක්වෙස්චන්ස්. අනේ ක්වෙස්චන් වල ළමයින්ගේ තියෙනවා අපේ අඩුවක්. මම මේ ලාස්ට් වීක් එක ගාම එහෙම කරා. එතන ඉතන ක්වෙස්චන්ස් විතර කරනකොට ඉතලා කට්ටිය නැහැ. අනේ ක්වෙස්චන්ස් නේ ඕනේ නැහැ. කියලා තියෙන සෙමිනාර් නේ ඕනේ නැහැ. සෙමිනාර් කියලා නෙමෙයි මම ක්ලාස් එකම තමයි සෙමිනාර් කියලා කරේ. question discussion is compulsory. The questions හරියට අහගන්න බෑ කියන්නේ network එකේ පොඩ්ඩක් trouble වුණාම එයා හිතනවා නෑද පස්සේ බලමු. වීඩියෝ බලලා එහෙම ඉගෙන ගන්න හරි අමාරුයි. පුළුවන් තරම් physically presence ඉන්න ඕනේ class එකේ. හරිද? කරන්නම දෙයක් නැති වෙලාවකට මිසින් වෙන එක අවුලක් නෑ. හරි. Okay. එහෙනම් අදට වැඩේ ඉවරයි. God bless you. Bye. Class is over.